Alright, this video is about complex numbers. And well, first thing I want to remind you of is that a complex number is always of the form a plus bi. So for example, 3 plus 2i, where 3 is the real component and I is the 2 is the imaginary component, is in standard form. 2i plus 3 is not in standard form. The imaginary term comes after the real. So if you were to represent an answer to a question in this form, you would lose points. That's not valid. When we add or subtract complex numbers, it's like adding and subtracting by combining like terms, just like you would do in normal algebra. So in this case, if it was 3 plus 2i plus 2 minus 3i, we would add the real terms, 3 plus 2, and we would add the imaginary terms, 2i minus 3i, and we'd get an answer. Okay, remember, by definition, I is the square root of negative 1, and if that's true, I squared equals negative 1. When we multiply complex numbers, for example, 3 times 4 plus I, we distribute it just like real numbers. You'll get that. 3 times 4 is 12, 3 times I is 3i. If you're actually doing 4 plus I times 2 minus 2i, okay, you'll FOIL it just like you would real numbers. 4 times 2 is 8. 4 times negative 2 is minus 8i. 2 times I is 2i. And I times 2i. Now this is negative 2i squared. Okay? You combine like terms. Minus 8i and plus 2i is minus 6i. But we still have this 2i squared. You can never leave an answer with an I squared, because I squared is the same as negative 1. So we get 8 minus 6i, minus 2 times minus 1 is plus 2, so we end up with 10 minus 6i. Okay, so never leave I squared in your answer, okay, but you'll FOIL these just like you would any other FOILing you may have done. You never leave an I in your denominator. So let's assume you were given this problem. Okay, what you need to do to get rid of an I in the denominator is you multiply by the complex conjugate over itself. So if 2 minus I is our denominator, the complex conjugate is 2 plus I. If I had given you 4 minus 3i, the complex conjugate is 4 plus 3i. Okay, you basically change the sign in front of the imaginary term to get the complex conjugate. The reason we do that is as follows. When we multiply these two now, we get 3 plus I times 2 plus I over 2 minus I times 2 plus I. In the numerator we FOIL. 3 times 2 is 6. 3 times I is 3i. I times 2, I times I. In the denominator, when we FOIL this, I want you to notice the form. This is like a minus b times a plus b. Okay? A minus b times a plus b is the same as a squared minus b squared. So you can go through the FOILing process, or you can recognize the pattern and just say, since this is a minus b times a plus b, I'll take a squared, which is 4, minus b squared, I squared. Alright, so let's come over here. Let's combine like terms. 6, 3i and 2i is 5i. Plus I squared means minus 1. In the denominator, I get 4 minus I squared being a negative 1. 6 minus 1 is 5. 4 minus a negative 1 is 5. Let's factor out a 5 in the numerator. And your answer is 1 plus I. So that's the basics of manipulating complex numbers. I can do addition and subtraction, which is simple. When I do multiplication, always remember I squared, negative 1. Never leave an I squared in your answer. Always take that I squared, make it a negative 1. And with division, you can never have an I in the denominator, and the way you get rid of it because you multiply by the complex conjugate over the complex conjugate, anything over itself. So we haven't changed the problem, but we use this relationship here as a way to get rid of any I in the denominator. The I's will go away when you multiply by the complex conjugate in the denominator there. So that's just simple complex number manipulation. Good luck.